Assalamu alaikum warahmatullahi wabarakatuh. Dear students, in this video we will learn how to solve examples from question bank of question number 4 from the chapter Arithmetic Progression. So first example, the sum of first 55 terms of an AP is 3300, then find its 28th term. So here the given thing is sum of 55 term, that is S55 is equal to 3300. We will find the 28th T, 28 is equal to question mark. So now let us consider, let A and D be first term and common difference of an arithmetic progression AP respectively. Let A be the first term and D be the common difference of an AP. Now we know that sum of n term Sn is given by the formula n upon 2 bracket 2a plus n minus 1 into d. Now for n is equal to 55, n is equal to 55, S55 is equal to 55 upon 2 into bracket 2a plus 55 minus 1 into d. Therefore, S55 is given as 3300 is equal to 55 upon 2 into 2a plus 55 minus 1 is equal to 54d. Therefore the next step, that is 3300 is equal to 55 upon 2 into, here in this 2, the 2 is common, 2 ones are 2 and 2 into 27 is 54. So 2 we can take common, 2 common, so A plus 27 2s are 54, 27D. Now this 2 numerator and denominator will cancel, 2 ones are 2, 2 ones are 2 will cancel. Therefore 3300, this 55 is multiplication, it will come on left hand side, it will get divided. 3300 divided by 54 is equal to A plus 27D. Dividing by 11, 11 5s are 55, 11 3s are 33, 0 0, 5 1s are 5, 5 6s are 30. Therefore 60 is equal to A plus 27D, equation number 1. Now for an AP, for an arithmetic progression, nth term of AP is given by Tn is equal to A plus n minus 1 into d. Therefore, for n is equal to 28, T28 is equal to A plus 28 minus 1 into d. Therefore, T28 is equal to A plus 28 minus 1, 27D. Therefore, T28 is equal to A plus 27D is equal to 60. So from 1, A plus 27D is equal to 60 from statement number first. Therefore, 20th term of an AP is Second example. Find the sum of numbers between 1 to 140 divisible by 4. Now, let us consider first the sequence of a number which are divisible by 4 between 1 to 140. So 1 is not divisible, 2, 3, 4 is the first number which is divisible by 4 between 1 to 140. Second, 8, 12, 16 and so on. The last number 140 is divisible, but we want between 1 to 140. So before 140, the number which is divisible by 4 is 136. So in this sequence, let us assume this first term as T1, second T2, T3 and the last term 136 is Tn, nth term of the sequence. Now let us first check whether the given sequence is 80. So first D1, common difference, D1 is equal to T2 minus T1, which is equal to 8, T2 is 8 minus 4, 8 minus 4 which is equal to 4. Then D2 is equal to T3 minus T2, that is 12 minus 8 which is also 4. Therefore, D is equal to 4 is constant. So the given sequence is an arithmetic progression. It is an AP. Now in this AP, the first term A is equal to 4 and common difference is also 4. Tn, last term of the sequence is 136. So here first we have to find n and then we have to find the sum, that is Sn. Now for an AP, we know that for an arithmetic progression, the nth term Tn is given by the formula A plus n minus 1 into D. Therefore, Tn, the last term, that is 136, is equal to A4 plus n, we have to find minus 1 into D is also 4. Therefore, 136 minus 4 is equal to n minus 1 into 4. Therefore, 136 minus 4 is 132 is equal to n minus 1. This 4 is multiplication here. It will come on left hand side. It will get divided. 4 ones are 4. 4 threes are 12. And 4 threes are 12. You will get as n minus 1. Therefore, n minus 1 is equal to 33 and n is equal to 33 plus 1 which is equal to 34. So n is equal to 34. A is equal to 4, D is also 4, n is equal to 34. We have to find Sn. So sum of n term, Sn is equal to n upon 2 bracket 2a plus n minus 1 into D. Therefore, S34 is equal to 34 upon 2 into 2a, 2 plus 2 into 4 plus 34 minus 1 into D is equal to 4. Therefore, here 2 ones are 2, 2 ones are 2, 17s are 34, 17 into 8, 4 2s are 8 plus 33 into 4. Therefore, 17 into 8 plus 4 3s are 12, 1 carry 132 plus 8. Therefore, 17 into 132 plus 8 is equal to 140, which is equal to 17 zeros are 0, 17 fours are 68, 6 carry, 17 ones are 17 plus 6 is 20, 3. So sum of the terms S34 is 2380. Therefore, the sum of numbers between 1 to 140 which are divisible by 4 is 2380. Third example, in a Mahila Bachat Gat, Sharwari invested rupees 2 on first day, rupees 4 on second day and rupees 6 on third day. If she saves like this, then what would be her total saving in the month of February 2010? So, the saving of Sharwari in the Mahila Bachat Gat is sequence is rupees 2 first day, second day 4, third day 6 and so on. Now in the month of February, how much? So month of February February 2010, the year 2010 is an ordinary year. So the days in the month of February in 2010 is equal to 28 days. Ordinary year, it has 28 days. So year 2010 is ordinary year which has 28 days in the month of Feb. Now therefore in the given sequence, let T1 be 8, T2, T2 be 4, T3 be 6. Therefore D1 is equal to T2 minus T1 which is 4 minus 2 which is equal to 2. D2 is equal to T3 minus T2, that is 6 minus 2 is also 2. So here D equal to 2 is constant. So therefore the given sequence, it is an arithmetic progression. Therefore we have here A is equal to 2, D is also 2, N is equal to 28. You have to find S total saving in the month of February, that is S28 we have to find. So we know the formula to find Sn, sum of n terms. Sn is equal to n upon 2 bracket 2a plus n minus 1 into d. Now put this value, a is equal to 2, d is equal to 2 and n is equal to 28 in the Sn formula. Sn S, therefore S28 is equal to 28 upon 2, n is 28 into 2a, a is 2 plus n 28 minus 1 into d is also 2. Therefore 28 upon 2 into 2 2s are 4 plus 28 minus 1, 27 into 2, that is 28 1s are 28, 21 2 1s are 2 and 2 14s are 28. So 40 into 4 plus 27 2s are 54. Therefore 40 into 4 plus 54 is equal to 58 is equal to 14 8s are 112, 2 carry 11, 14 5s are 70, 70 plus 11 is 81. So total saving of Sharwari in the month of February 2010 is rupees 812. Fourth example, find the sum of odd numbers from 1 to 101. Now, odd numbers are the numbers which are not divisible or multiple of 2. So, the numbers which are not divisible by 2 are, first is 1, from 1 to 101, 1, then 3, 5, 7 and so on. The last number, odd number is between 1 to 101 is, last is from 1 to 102, 1 to 10 is 101, the last number. So let T1 first term is equal to 1, T2 3, T4 2, T3 5 and so on. The last term, this 101 be Tn. Here we have to find, first let us see whether let A be the first term and D be the common difference. So D1, D is equal to 3 minus 1, 2, D2 is equal to 5 minus 3 is also 2. So here D is equal to 2 is constant. Therefore, the given sequence, it is an arithmetic progression. Now let A be the first term and D be the common difference. So A, T1, that is first term, A is equal to 1, D is equal to 2, last term Tn is equal to 101. We have to first find the n using Tn formula and then Sn, sum of the odd numbers from 1 to 101. So for an AP, for an arithmetic progression, Tn is equal to A plus n minus 1 into D. So Tn is given as 101 is equal to A is equal to 1 plus n minus 1 into D is equal to 2. Therefore, 101 minus 1 will come on left hand side, it will become minus is equal to n minus 1 into 2. Therefore, 101 minus 1 is 100 is equal to n minus 1, here 2 is into, here it will come, it will get divided. 2 1s are 2, 2 5s are 10, 50. Therefore, n minus 1, get as n minus 1 is equal to 50. Therefore, n is equal to 50 plus 1, which is equal to 51. N is equal to 51. Now first term A is equal to 1, last term Tn is 101, n is equal to total number of odd numbers between from 1 to 101 is 51. We have to find Sn, that is S51 we have to find. So we know the formula, Sn is equal to n upon 2 bracket first term plus the last term. When first term and last term is given, we can use this formula, Sn is equal to n upon 2 in bracket A plus the Tn, last term. Therefore, Sn is equal to 51 is equal to 51 upon 2 into A is equal to 1 plus last term 101. Therefore, 51 upon 2 into 101 plus 1 is 102, 2 1s are 2 5s are 10 is equal to 1. 51 into 51, 51 1s are 51, carry 5, 51 5s are 225 plus 5 is 230. So S51 is equal to 2301. So sum of odd numbers, answer, sum of odd numbers from 1 to 140 is 2301. Fifth example, Subhankar invested in National Savings Certificate Scheme In first year, he invested rupees 500. In second year, rupees 700. In the third year, rupees 900, and so on. Find total amount that he invested in 12 years. So the investment done by Subhankar is rupees 500 in the first one, rupees 700 in the second year, rupees 900 in the third year, and so on. He invested for 12 years. So here first let this sequence T1 be 500, T2 be 700, T3 be 900. So we'll check whether the sequence is AP. So D1 is equal to T2 minus T1, that is 700 minus 500, which is equal to 200. D2 is equal to T3 minus T2, that is 900 minus 700 is equal to 200. So therefore D is equal to 200 is constant. Therefore given sequence, it is an arithmetic progression. Therefore first term A is equal to 500, that is T1. D is equal to 200. The n number of years is given as 12. We have to find Sn, that is total investment in 12 years, that is sum of investment sum done in the 12 years. S12 we have to find. So we know that formula to find Sn. Sn is equal to n upon 2 bracket 2a plus n minus 1 into d. So Sn, that is Sn is equal to n is equal to 12 upon 2 in the bracket 2 into a 500 plus 12 minus 1 into d is 200. Therefore Sn, that is S12, n is equal to 12. Therefore S12 is equal to 12 upon 2 in bracket 2 into 500, that is 1000 plus 12 minus 1, 11 into 200, that is 6 to 1 are 2, 2 6 are 12. So S12 is equal to 6 into 1000 plus 11 into 200, that is 2200, which is equal to 6 into 2200 plus 1000, 3200 into 6, 0, 0 are 6 zeros, 6 2s are 12, 1 carry 6 is 18, that is rupees 19,200. The investment done by, that is Subhankar invested in National Saving Scheme, certificate scheme, rupees 19,200 in 12 years.